Good afternoon. Let us continue the problems from continuity and differentiation exercise problem. Let me start with the problem number 1 itself. Discuss the continuity of the function f of x equal to mod x minus 5 in the set R. Discuss the continuity of the function f of x equal to mod x minus 5 in the set R. Actually, f of x means only modulus mod x minus 5. Now, I can write the same function like this. It is modulus of this for all x less than 5. For all x less than 5, just imagine 4. 4 minus 5 minus 1, modulus is 1. So, I can write it as 5 minus x. See, it is the modulus. For all x less than 5, just to observe, this will be the modulus for x minus 5. And for all x greater or equal to x minus 5 itself is the modulus. So, we can write the same function like this. Now, let us consider two intervals, which are they? Minus infinity to 5, 1, and 5 to infinity. Consider two intervals. Let me use the property of the continuous function itself. Since, see like this, 5 minus x is a linear equation. Continuous in minus infinity 5. See, why should I write all the limit, other things? Just now we know this. All the polynomial functions are continuous. Let me write it straight away. Linear equation means a polynomial. Continuous in the interval this. Also, x minus 5 is a continuous, a linear function, linear equation, continuous in 5 infinity. So the thing is, we have to verify whether it is continuous at x equal to 5, that's all. At x equal to 5, limit x tending to 5 minus f of x, limit x tending to 5 minus left hand side limit x less than 5, this equation. 5 minus x, 5 minus x, 0. 5 minus 5, 0. Limit x tending to 5 plus f of x, limit x tending to 5 plus x minus 5 minus x, 5 minus 5, 0. Positive side, I have done a mistake here. X less than x minus 5, for x greater than 5s, x minus 5, but 5 minus 5, 0. X less than 0, this one is the equation. Greater than x, approaching 5 from the positive side, this one is the equation. Finally, f of 5 is less, greater or equal to 5, same equation. 5 minus 5, 0. Since, conclusion is here, since limit x tending to 5 minus f of x limit extending to 5 plus f of x equal to f of 5, f is continuous at x equal to 5. So it is continuous everywhere. Therefore, f is continuous everywhere in R over left hand side limit, right hand side limit, value of the function at this. Already it is continuous in the interval. In the open interval this. Now at x equal to 5 also it is continuous. So no doubt the function is continuous in the entire real number set. Problem number 2. Discuss the continuity of the function. Discuss the continuity of f of x equal to mod x by x if x not equal to 0, 0 if x equal to 0. In the set R. Yes, now there are two intervals, minus infinity to 0. Let us consider two intervals minus infinity up to 0 and 0 to infinity. Let C be the element belonging to the first interval. Limit x tending to C f of x equal to limit x tending to C f of x mod x by x equal to limit x tending to C. Now approaching x, C is in the interval minus infinity to 0 means the C is already negative. Number considered is a negative number, C, minus infinity 0. Modulus of the negative number is minus of that. So I can write this one as minus x by x. Why? Modulus of a negative number is a minus of that. If this one is a minus 1, modulus is plus 1 means what? Minus of minus 1. Same thing. X is already negative. One more minus is positive. So total it is minus C by C or minus 1 we get. Again, f of C equal to mod C by C, or this is minus C by C minus 1. So it is continuous. Since limit x tending to C, f of x equal to f of C, f is continuous in minus infinity to 0. It is continuous. Next, limit, or let me consider one more, let c equal to 0 infinity, next interval. Limit x tending to c, f of x equal to limit x tending to c mod x by x equal to, c is already positive. Modulus of the positive quantity is same, therefore it is 1. It is 1. F of c equal to mod c by c, c by c 1. Since limit x tending to c f of x equal to f of c, f is continuous in 0 infinity also. Minus infinity is 0, continuous. Now it is continuous in 0 infinity. Last thing is at x equal to 0, you have to see. That is all. Limit x tending to 0 minus f of x. Limit x tending to 0 minus mod x by x. Mod x by x from the negative side of this, minus x by x, limit minus x by x, minus 1. Limit x tending to 0 plus f of x, limit x tending to 0 plus mod x by x, limit x tending to 0 plus x by x 1. Here it is minus 1 because when it approaches 0 from the negative side, modulus of the negative quantity is minus x. If it approaches 0 from the positive side, modulus of x is x itself, 1. Since limit x tending to 0 minus f of x not equal to limit x tending to 0 plus f of x, f is discontinuous at x equal to 0. Point of discontinuity is x equal to 0. Over problem number 3, discuss continuity of f of x equal to x plus 1 if x greater or equal to 1, x square plus 1 if x less than 1 in the set R. Here also let me use the property of the continuous functions. For all x greater or equal to 1, so let us consider two intervals. Let us consider two intervals. minus infinity to 1 and 1 to infinity. F of x equal to x plus 1. See, just see here, it is the linear equation. X plus 1, polynomial equation of degree 1. So, x plus 1 is a polynomial function continuous in minus infinity 1. Just by using the property of continuous functions, you can write polynomial function is always continuous. F of x equal to x square plus 1 is a polynomial function continuous in 1 infinity. So the thing we have to do is at x equal to 1 what? Minus infinity to 1 linear equation continuous. 1 to infinity x greater or equal to 1. Have I done mistakes here? X less than 1. 2 interval minus infinity 1, 1 infinity is a polynomial function continuous. Remember, equation has been changed. Let me do like this. X square plus 1, x plus 1. For all x less than 1, this one is the equation. See, minus infinity 1, x square. For all x 1 to infinity, x greater or equal to 1, this, right. Greater 1 is given in the above, less than 1 is given below. Anyway, at x equal to 1, limit x tending to 1 minus f of x, limit x tending to 1 minus x less than 1, this is the equation. X square plus 1, 1 square plus 1, 2. Right hand side limit x tending to 1 plus f of x, limit x tending to 1 plus x greater than 1, x plus 1, 1 plus 1, 2. F of 1 equal to greater or equal to 1, this. All are equal. Since limit x tending to 1 minus f of x, limit x tending to 1 plus f of x, and f of 1, f is continuous at x equal to 1. So, the given function is continuous everywhere. Therefore, f is continuous everywhere. Yes. Given function is continuous everywhere in the interval as well as at x equal to 1. Next problem. F of x equal to, discuss the continuity of the function. Problem number 4th. Discuss continuity of the function f of x equal to minus 2 if x less or equal to minus 1. 2x if minus 1 less than x less or equal to 1. 2 if x greater than 1. In the set R. In the set R. Actually, you have to divide it into 3 intervals now. Let us consider 3 intervals. First one, less or equal to -1. Minus infinity, -1. Next one is -1, 1. And 1, infinity. F of x equal to -2 is a constant function, continuous everywhere. In the first interval, function is continuous. 2x linear equation, it is also continuous. Again, constant function, continuous. Problem is to see whether it is continuous at -1 and 1. That's all. At 2 different places, you have to see whether given function is continuous. So let me write step by step. First one is f of x equal to -2 is a constant function, continuous in minus infinity -1, 2x. F of x equal to 2x, polynomial function, continuous in -1, 1. 2. F of x equal to 2 is a constant function, continuous in 1 infinity. 1 infinity. Now, thing is, first of all, let me see. At x equal to, first breaking point is -1. Again 1. -1. Limit x tending to -1 from the negative side, less than -1. This equation. F of x equal to limit x tending to -1, -2, -2. Positive side, limit x tending to -1, but from the positive side, x greater than -1. This one, 2x. F of x, limit x tending to -1 plus 2x, 2 into -1, -2. F of -1 is -1 less or equal to -1, -2. Since limit x tending to -1 minus limit x tending to -1 plus and value of the function at -1. F is continuous at x equal to -1. Next, one more thing is there. At 1 you have to see. At 1, at x equal to 1, limit x tending to 1 minus 1 minus f of x equal to limit x tending to 1 minus less than 1, x less than 1, 2x. 2 into 1, 2. Limit extending to 1 plus f of x. Limit extending to 1 plus positive side. X greater than 1, 2. 2. F of 1. F of 1 for all x. For all x less or equal to 1, it is 2x. 2 into 1, 2. All are equal. Since limit x tending to 1 minus f of x, limit x tending to 1 plus f of x equal to f of 1, f is continuous. F is continuous at x equal to 1. Since it is continuous at minus 1 and 1, f is continuous everywhere. F is continuous everywhere. Discuss the continuity of the following functions. Discuss the continuity of f given below. Given below in the set R. F of x equal to 2x if x less than 0. 0 if 0 less or equal to x less or equal to 1. 4x if x greater than 1. 2x, x less than 0. 0, 0x 1. 4x, x greater than 1. This is homework for you. Try to work out. Yes? Okay.